Yeah, bro, could you mute yourself? Could you mute yourself? Yeah.
The training later in section 4 will be relatively, let's say, fast, so that we don't have to wait a week for our model to finish the pre-training. So this text consists of 20,000 characters, and this is a public domain book that we can use, and I'm just using a very, very small book for illustration purposes so that the training
two use cases in the field and install it. So this is my regular expression.
Tokenization breaks down the input text into individual tokens. What does it do? I had always thought Jack convert tokens into token IDs. Next, we'll convert the token into token IDs that we can via embedding layers later. For this, first we need to build vocabulary. Tokenization breaks down the input into individual tokens. Tokenized training data set. Each unique token is added to the vocabulary in alphabetical order. Okay, so each token is added to the vocabulary to a specific token ID, which makes sense, of course. You have to. This vocabulary contains unique alphabetical order. Each unique token is mapped to a unique. Okay, each of them is mapped to a unique. It's a lot of mapping. Cool. Training set consists of one sentence of illustrating purposes. Input text. The quick brown fox jumps over the lazy dog. Brown dog fox jump lazy over quick dog. Okay, all of this is getting mapped. Cool. The vocabulary contains unique words. All words sorted, set. What does this look like? All of them are sorted. We are enumerating the things, the word with the token. Okay. for I in item, vocab items. Below, we illustrated the tokenization of a short sample text using a small vocabulary. Tokenization breaks down the training set. For I in item, enumerate vocab items.
And yeah, it's just regular text, plain text. So here is an excerpt of the first 100 characters, essentially. And like I've shown you earlier in the figure, the goal here is first to tokenize the text, which means breaking it down into individual tokens, which are words, punctuation signs, and so forth. And yeah, it's actually a big topic itself. It could be the whole 4-hour lecture discussing how tokenizers work, but tokenizers are not really the LLM itself. So in this case, I will only show you a simple tokenizer and then show you a tokenizer that is used for GPT models. But just to get an idea of how it works, here's a simple tokenization scheme. So here I'm using a regular expression that splits text based on white space characters and punctuation and so forth. So everything will be kind of split like you can see here. If you are not familiar with regular expressions, even that is probably a 2-hour topic by itself or even longer. So yeah, I'm really not that good at regular expressions anymore, thanks to LLMs, because you can actually also ask LLMs to help you with generating certain regular expressions. The idea here though is that we are splitting the text into these tokens. So actually I don't need this line, even it's redundant. So I'm splitting the text into tokens here, and you can see it's essentially one word per token, and then we also have the white spaces here as separate tokens. So these are the first 38 tokens here. If I then print the length, so we have 9,000 tokens. So that's the total number of tokens in the verdict data set. We can also take a look at the unique tokens. So for example, I can do length and then the set. So in Python, the set gets rid of duplicates. It's basically just unique entries. So I can do length preprocessed here, and this should give me the number of unique tokens. So we have 1,133 unique tokens in this data set. Next, actually I can also show you this if you're interested. Reprocessed. So these are basically the unique tokens. These should be the unique tokens, of course. So these are not containing the white spaces anymore. They're just the unique tokens. I can also maybe sort them alphabetically. Let's see. So yeah, here we have the unique tokens in increasing order. In Python, usually capitalized words go before the lowercase words. Okay, so next we can convert these tokens into the token IDs. But for that, before we can do that, there's one more step, and that is building a so-called vocabulary. So looking at this figure, we, let's say, have a training data set. This would be the verdict that we just looked at. The first step that we already did is we tokenized this data set, which means we took this and converted this into these individual word tokens. Now the next step is to build this vocabulary from all the tokens in the training set. So for that is
Sometime back in my AI services company, Atlic Technologies, we built a log classification system for our US-based client. The problem was complex, so we had to use hybrid classification system, where for fixed patterns, we use regular expressions in Python. For complex patterns, where we had enough training samples, we used BERT encoding and logistic regression. And for complex patterns where we didn't have enough training samples, we used LLM. In this video, I'm going to build that exact same project in front of you. For obvious reasons, we are going to use synthetic dataset, and the problem domain is changed a little bit, but the technical architecture and approach is exactly the same. In terms of tech stack, we'll be using DeepSeek R1 or Llama, BERT, post 2010. We are scoping down our work. When I worked in industry at Bloomberg and Nvidia, business managers would come up with big projects, and they will have so. Once you create that account, see, let me open this in incognito mode. It will say sign in using Google. So here you can sign in, and then you will come here. Okay. Now there is this concept of agent. So I have already built this chatbot, so it is showing this. But let me create a new one. So here I will say create a new agent. So new agent is essentially your new chatbot. Okay. And here my chatbot name is Mira. Mira chatbot for food delivery. And it's a long name, but whatever. And then I can just say create. So when you create this, it will use Google Cloud actually. So this project is already on the cloud. You're not building locally, by the way. You are already building this particular project on the cloud. So it already context colon ongoing order. And I can see, I can
I mean,
For that, what we do is we take or consider each unique token and add it to the vocabulary in alphabetic order, which is kind of like what I've done here. So here I extracted all the unique tokens, and next, once we have these unique tokens, we assign a unique token ID to them. So here they're in alphabetic order, and then I'm assigning a token ID, essentially, just an integer number. You can think of it just like a unique mapping from word to integer. So how I do this is, so here's actually the same code I used earlier above. So to get the unique tokens, I'm calculating the vocabulary size, which is equal to the unique tokens, the number of unique tokens. And here now I create this dictionary. So I say for each, so let's do this maybe step by step. So for each word, so sorry, for each word, I have a for loop for I in enumerate. So this will be giving me IDs from 0 to 1. So I can do print I, and you will see it will go from 0 to 1132. And it will give me also the corresponding token. So because enumerate gives me the number, the index, along with all the unique tokens. So what I'm doing now is I'm using the token and map it to the integer. So I'm basically reverting this. Instead of from integer to token, I have token to integer. So I can actually take a look at this. Actually, I have it already here, so I need to retype it. So I can actually look at the, let's say, first 50 entries and can show you then how this looks like. So here we have now the tokens mapping to these IDs, and you can see the punctuation characters come first, and then we have them in alphabetical order. So each, kind of like here, each unique token maps to a unique token ID. In this case, we have 1,133 token IDs. And yeah, and then once we have this vocabulary, we store this vocabulary because we need to use it now to convert our text. So we have some sample text here. We tokenize it, which is what we've already done, and then we use this vocabulary that we have just built to convert it into token IDs. So now we are using this tokenized text and convert it to token IDs using this vocabulary. And yeah, you might wonder where do these numbers come from. That is because how our vocabulary is constructed. So maybe let's see. It would be down here, but the would be corresponding to token ID 7. So if I scroll up a bit here, so this would be the last entry. It would correspond to ID 7, and then vocabulary brown corresponds to 0, dog corresponds to 1, and this is how we come up with 701 by just looking up the respective token IDs for these words. We could put everything together into a Python class, and this will make it easier to use this in practice, this concept. So here I have a simple tokenizer class, and before I show you maybe the code, or before I discuss the code, let's take a brief look at the figure here. And so what this tokenizer class is supposed to do is it's supposed to encode text.
And this is data. And the architecture, pre-training, bait training, fine-tuning.
Like here, so you have text, and then you encode it, and the encoding will essentially break down the text into tokens. You can then use the vocabulary to convert these tokens into token IDs. And then there's also a reverse function. It's this This tokenizer decode method, and this method will take token IDs. So when we have token IDs here, convert it back into these token.
Sample.